Hello everyone. In this video I'm going to solve exercise 2.2 question number 1 Roman 4. In the previous videos we have introduced what is a polynomial. We have solved question number 1 Roman 1, 2 and 3, and now here I'm going to solve, in this video I'm going to solve question number 1 Roman 4. Now how do we do this? Now this is your given polynomial. This is a polynomial with variable u, okay, having u as the variable. So this is a polynomial in u. So I'm going to represent this polynomial by p of u. So your given polynomial is 4u square plus 8u. Now I'm going to find out the zeros, okay. So in order to find out the zeros of this polynomial, first you equate your polynomial to 0. So let 4u square plus 8u be equal to 0. Now this is a quadratic polynomial. Now in the previous videos we have seen solving a quadratic polynomial by factorization, process of splitting the middle term. But even though it is a quadratic polynomial, we have only two terms. Okay, so in order to solve by the method of splitting the middle term, we need to have three terms. Since we have only two terms here, so we cannot apply the method. So what we are going to do here, how are we going to solve this? Here, see, 4u square plus 8u, we cannot add them because they are unlike terms. So the only way that we can solve this is either by the method of completing the square, or we can just solve this by taking some common terms from this. 4u square plus 8u, here we can take 4 as common and u as common. So 4u is common from both these terms. So if we take 4u as common term, then from this first term we will have only u. And from the last term we have only 4, 2 times is 8. Okay? So this polynomial has been factorized. So product of two terms is 0. Means either your first term is 0 or your second term is 0. For u is 0 implies u is equal to 0 upon 4. So this gives you u as 0. U plus 2 is 0. This implies u will be equal to minus 2. So the values of u are 0 and minus 2. This values of u is known as the 0 of your polynomial. So I'm going to write here, therefore, zeros are 0 and minus 2. 0 and minus 2. Now since we have obtained the zeros, so let's find their sum. So sum of zeros. Sum of zeros means adding up your zeros. First 0 plus second 0. 0 plus minus minus 2. That is equal to minus 2. And then product of zeros. Product of zeros means we multiply these zeros. 0 into minus 2 gives you 0. So we have obtained sum of zeros and product of zeros only after determining the zeros, right? But without determining the zeros, knowing your polynomial, we can also find the sum and product of zeros. Let's see how. The formula for determining the sum of zeros is minus coefficient of, do not write coefficient of x here as in the previous question because your polynomial is in u. So I'm going to write minus coefficient of u upon coefficient of u square. Now this negative from the formula, look at the polynomial coefficient of u. Coefficient of u here is 8. So I'm going to write here 8 upon upon coefficient of u squared, which is 4. So I'm going to write here 4. 4 2 times is 8. So the sum of the zeros is minus 2. Similarly, so the sum of the zeros here and the sum of the zeros here are equal. Okay, so that part is verified. And then product of zeros formula would be constant term upon coefficient of u squared. So the constant term, what is the constant term in this polynomial? This is a term containing u squared, this is a term containing u. There is no constant term. Constant term is a term without the variable. So there is no such constant term here. So since the constant term is absent, so your constant term here will be 0, and the coefficient of u squared is 4, 0 upon 4. If the numerator is 0, result is 0. So the product of zeros obtained here and the product of zeros obtained here are equal, hence your solution is verified. Alright? Okay. Let me solve one more question. Roman 5 in this video. Let me just... Okay, I'll be needing these formulas, so I'm not going to rub these out. Let me just do this way. Okay. So Roman 4, what we have is your given polynomial is t square minus 15. T square minus 15. Okay, this is your polynomial. Here, this is your polynomial, t being the variable. Okay, so your polynomial is in t. So I'm going to denote this polynomial by pt, which is t square minus 15. In order to find the zeros of this polynomial, we will first equate this polynomial to 0. Alright? Okay. Now here, what we have to do is, it's a quadratic polynomial, but we have only 2 terms, so we cannot solve it by the process of splitting the middle term. We can neither subtract them, nor no common elements are present, right? There is no common terms. Okay? There is no common terms from this, so we cannot solve like the previous question. But what we can do is, we can just simply find the value of t here. T square, okay, this minus 15 can be transposed to the right hand side as plus 15. Now in order to find out the value of t, the square also needs to be transposed to the other side. So if you transpose this square to the other side, then it becomes plus or minus square root of 50. Okay, square being transposed to the other side, it becomes plus or minus square root. Therefore, we have got 2 values of t. The first value of t is plus square root of 15, and the other value of t is minus square root of 15. So these are your zeros. So the zeros are plus square root of 15 and minus square root of 15. Now since we have obtained the zeros, so we can find their sum. So sum of the zeros. First 0 plus your second 0. So this is root 15 plus minus minus root square root of 15. Square root of 15 minus square root of 15, 0. Product of zeros, we need to multiply your zeros. Square root of 15 times minus square root of 15. Let me first write the negative sign. Square root of 15 times square root of 15. Same terms, if you're multiplying twice, then we need to write square root of 15, the holding square. Square and square root, they will cancel out. So we have minus 15 over here. Now let us verify using the formula. Sum of the zeros means, here your variable is t. So I'm going to write here, sum of zeros minus coefficient of t upon coefficient of t squared. So minus from the formula. Oh, in your polynomial there is no term containing t. This is a term containing t squared. This is your constant term. There is no term containing t. So in that case, the coefficient of t will be 0 and the coefficient of t squared, the numerical value present with this t squared, will be 1 only. So 1. So 0 upon 1, 0. So your sum of the zeros is verified. And then the product of the zeros, constant term upon coefficient of t squared. Your constant term. What is your constant term here? Minus 15. Coefficient of t squared is 1, so we have minus 15. So we have equal product of zeros. Hence your solution is verified. Alright?